Have you ever sent a text? Or maybe binged a show on your phone? Well, every time you do that, you're using a language you've probably never even spoken. Today, we're going to crack that code. We're diving into how we actually talk to computers and looking at the basic instructions that power, well, our entire digital world.
So really, think about it. How do you tell a computer what you want? I mean, you can't just say, hey, build me a website and expect it to happen. There's this huge gap, right? A language barrier. And bridging that barrier, that's what programming is all about. To get our ideas across, we need a translator. It's that simple. See, computers at their core only understand raw binary, just ones and zeros. But we think in words, in concepts. So what we do is we write instructions in a special language that we can actually read, and then a program translates that into the machine's native tongue. Now, these translators come in two main flavors. On the one hand, you've got a compiler. Think of it like a book translator. It takes your entire program, reads the whole thing at once, and spits out a fully translated version that runs super fast. On the other hand, you have an interpreter. This is more like a live diplomat at the UN. It translates and runs your code line by line in real time. This is amazing for learning because you can find your mistakes as you go. For our little journey today, we're going to use one of the most popular and honestly one of the friendliest translators out there, Python. And yeah, you guessed it, Python uses an interpreter, which makes it absolutely fantastic for getting started because you get that immediate feedback.
So, a little backstory on Python. It was created back in the early 90s by a programmer named Guido von Rossum. And you'll hear it called a high-level language. All that means is that it's designed to be closer to human language, which makes it way easier for us to read and write than the super complex code the computer actually understands. And this is where the conversation happens. This little window is called the Python shell. See those three little arrows? That's the prompt. That's basically the interpreter saying, okay, I'm listening, give me your first command.
But here's the catch. You have to speak its language perfectly. Look here, on the left, we've got a correct command, but on the right, whoops, we forgot the quotes around the text, and bam, syntax error. Programming languages have incredibly strict grammar rules, what we call syntax. If you break them, even by a little bit, the interpreter just throws its hands up and says, sorry, I have no idea what you're talking about.
Okay, so if we're going to build something, we need materials, right? In programming, our materials are data. So before we can even write instructions, we need a way to store and label all that information. Let's look at the most basic building block for doing exactly that.
And that fundamental container is called a variable. Honestly, the best way to think of it is just as a labeled box. You give the box a name, and then you put something inside it. That something could be a number, a piece of text, maybe a player's score in a game. Literally anything you need the computer to remember for later. This right here shows that idea perfectly. We've created a variable, a box, named X, and we've put the text ICT inside it. That's it. Now from this moment on, whenever we talk about X, the computer knows we mean ICT. We've officially stored a piece of information. And that piece of text we just stored, it has a specific name. It's called a string. Anytime you're working with text and programming, a username, a password, a title of a web page, it's a string. And the number one rule is you always have to wrap it in quotes. Okay, so we've got our ingredients, our variables, and our strings. Now we need the recipe. We need the logic that tells the program what to actually do with that information. This is where programs start to get smart.
We call the verbs of programming control structures. These are the commands that don't just sit there holding data. They actually do things. They are the directors of your program, controlling the flow and the sequence of events. And they pretty much come in two main flavors. First, you've got selection. This is all about making decisions. Think, if your password is correct, let you in, else show an error message. Then you have repetition, or what we call loops. This is the real workhorse. It lets you do something over and over and over again without having to rewrite the same code. And here is a perfect example of a loop in action. The code is basically saying, hey, for every single character you find inside the box X, print that character out. And look at the output. I, then C, then T. This one simple idea is how your social media feed scrolls endlessly, or how a video game updates the screen 60 times every second. It's all just loop. So let's step back. We have variables to hold our data, and we have control structures to create logic. Now, it might seem pretty simple, but these two things are the atoms. They are the Lego bricks from which entire digital universes are built. Let's see what that looks like on a grander scale. So what can you build with just those basic blocks? Well, pretty much anything you can imagine. We're talking about complex artificial intelligence that can learn on its own, the web apps and e-commerce sites we use every single day, powerful tools that can sift through mountains of data to find hidden patterns, and even things called software agents.
So let's talk about that last one, a software agent. What is that? Well, it isn't just a program that sits there and waits for you to click a button. No, this is a program that's designed to act on its own, on your behalf, to get something done. Think of it like a little digital assistant that's always working for you in the background. And I guarantee you already know some very famous software agents. Siri, Cortana, these are the perfect examples. They are incredibly sophisticated programs that understand your goals, like set an alarm for 7 a.m. or what's the weather like, and then they go and take all the necessary actions to make that happen without you having to guide them step by step.
So here's the main thing to remember. Everything, and I mean everything, from the simplest little app on your phone to the most advanced self-driving car is built from these same core principles. It all just boils down to storing information in variables and using logic, loops, and decisions to act on that information. That's really the secret.
You know, the entire history of computing has really just been about us taking our own logical processes and teaching them to a machine. And we've gotten so good at it that these machines can now outperform us at a lot of those tasks. So the real question now is, what problems are we going to solve, and what new worlds are we going to build with that power?